In this question, they give us a 0.10 mole per liter solution of lactic acid, a weak acid found in milk, has a pH of 2.43. Now, they're going to ask me to find the percent reaction of this, find the Ka value from this. We don't know the Ka. So what I've been given here is the concentration of the acid is 0.10 mole per liter. And they're telling me the pH. And so the pH is 2.43. And as soon as I see that, I can know the concentration of hydronium at equilibrium. So that's going to be 10 to the negative 2.43 or 10 to the negative pH. So if I put that number into my calculator, I can find out that this is 3.72 times 10 to the negative 3 mole per liter. So that's actually 3.7 because this has only got two significant digits. So at this point, I've got the acid, whatever the formula is for lactic acid, plus water is going to react to make hydronium and whatever the anion is for lactic acid, the lactate ion. I know that the concentration of my acid to initially is 0.10 mole per liter. And the hydronium ion concentration when I start out is 0, and my anion, whatever the lactate ion, is 0. At this point, I couldn't complete this, but because I know the concentration of the hydroniums is 3.7 times 10 to the negative 3, or 0.0037 mole per liter. This is going to be the same value, so I'm making that in my products. And I'm using that up in the reactants. And because they're 1 to 1 to 1, I'm not actually showing the times 1 over 1. But this is going to be minus 0.0037. And this does not actually line up. So this is going to be 0.10. So because I can't subtract these numbers from an unknown value, right? I don't have decimals there. So my Ka is going to be equal to the concentration of the hydroniums times the anions divided by the acid. So it's going to be equal to 0.0037 mole per liter squared, because it's these two numbers times each other, divided, so these are the same numbers, so I can square it, and then 0.10, and my Ka will be calculated that way. So if I square that equals and then divide by 0.1, I get 1.38 times 10 to the negative 4 is the Ka. And since I only had two sig digs, this is actually 1.40, or pardon me, 1.4 times 10 to the negative 4. Now, for the percent forward reaction, though, the percent reaction, this is the amount of hydronium that's made, but this is actually the quantitative amount that could be made. So the most I could possibly make, if it was quantitative, is 0.10 mole per liter. But I'm actually only making 0.0037 mole per liter. And then I'm going to multiply that by 100%. So 0.0037 divided by 0.1 equals times 100. I'm getting 3.7% forward reaction. So I've calculated the Ka, and the hydroxypropanoic acid and propanoic acid. Propanoic acid is, its Ka is 1.3 times 10 to the negative 5. And so this is 2-hydroxypropanoic acid. So by having this extra hydroxyl, it ends up being a stronger acid, and it is going to be less attractive to a proton if it's a stronger acid. It's a better donor. So that's kind of how you approach this question. I want you to recognize that in the case where they're giving you the initial concentration and they give you the pH, you should fill in an ICE table before figuring it out, because we can't know for certain whether we are going to be able to just round this off or if this change affects this number. So that's really an important thing to remember.